Welcome to 5 Minutes to Code, Programming Basics with your host Matthew C. Applegate. In this series we are going to look at the fundamentals of computer programming. So whether you are hoping to program in Python, to code in C#, or to develop in Java, these short guides should help you get to grips with the basics. You won't need to download or install any software, so just sit back and enjoy. In this series we are going to be looking at binary, hexadecimal, data storage, logic gates, and logic circuits. Today we are looking at data storage. Let's look at this in more detail. Several different things can be stored on a computer system: numbers, text, images, sound, and video. And each of these types of files have different methods of storing them on a computer. First, let's look at how text is stored on a computer. Text can be stored in two different formats: ASCII or Unicode. ASCII uses 8 bits to store its letters, therefore each letter will take up 1 byte in memory, which is great and useful for standard English. However, it can only handle up to 256 different types of character. Unicode, on the other hand, takes up to 2 bytes to store a character in memory, but they can have up to 65,536 different types of character. It takes up a lot more memory, and for this example is actually unnecessary. However, characters with special symbols or pronunciation would require the extended character set available in Unicode. Let's have a quick look at how graphics are stored. In older computers with monochrome graphics, text characters and symbols were drawn using binary. The zeros represent an empty space, whereas the ones represent a drawn pixel. Each potential pixel on the screen uses 1 bit. As the color is very limited, it allows the file size to be very small by modern standards. This entire image would take up 8 bytes. However, modern computers with their vast color range require a great deal more information about each pixel. In fact, each pixel on the screen is made up of 3 values: R, G, and B, which stands for red, green, and blue. So each pixel drawn requires a number of values between 0 and 255. This, as you can imagine, takes up a lot more memory. So this image, which although is the same number of pixels as the previous example, actually takes up to 192 bytes to store. There are also additional factors to consider, like high-end graphics cards, which allow for even more information per pixel to be required. But that discussion's for another time. Let's look at how sound is stored in a computer. Sound needs to be converted from an analog signal into a digital signal for it to be understood by a computer. Sound would be captured by an analog to digital converter, or ADC. It would capture the samples at regular intervals, the intervals of which are determined by the bit rate. The more samples they collect per second, the more accurate replication of the sound and the larger the file size. If I were to capture sound at a bitrate of 16 samples per second, it will convert the analog signal into a digital one, and as you can see by the graph, it loses a great deal of the information, chopping bits off here and there to make a best match for the sound. If I were, however, to capture sound at a much higher bitrate, say 32 samples per second, it would convert it in a much more accurate way. You may hear of different file values when dealing with MP3s or video files. For example, 128 kilobits per second, 192 kilobits per second, and 320 kilobits per second. The lower the kilobits per second, the lower quality of sound. So there you have it, data storage in a nutshell. Of course, there is a lot more to it. This is just a simple introduction to get you started. I hope you have enjoyed the video. If you have, be sure to subscribe to my channel, like the video, and comment below if you found it useful. If you want to get started in programming right away, be sure to check out my computer art programming tutorials here. Until next time, thanks for watching 5 Minutes to Code.